This video is for those of you that missed class yesterday about, for the field trip or whatever your reason was. You had two sets of notes in your folder. One that's called absolute value equations and the other is absolute value inequalities. So I'm going to start with the absolute value equations. My suggestion is just to fill these notes out, and then when you come in next class I can show you how you're supposed to fold them, and then you can put them in your notebook. So I'm going to start with the absolute value equations, and we need to recall that absolute value is the distance a number is from zero. Okay, so for example, absolute value of 4 is 4 spaces from 0, and so is negative 4. Okay, so that means an absolute value equation is an equation containing absolute value. Not very interesting in its description. So for example, we're going to solve the absolute value of x equals 9. So we know what this says is that what value is 9 spaces away from 0. So I get x positive 9 is 9 spaces from 0, and so is negative 9. Alright, so we're going to make it a little bit more complicated, and we're going to solve the absolute value of x plus 4 is equal to 3. So what this means is that whatever I plug in for x and add 4 to it, that it is not 3 spaces away from 0. So whatever's inside of here could equal positive 3, because that's 3 spaces from 0, or it could equal negative 3, because that is also 3 spaces from 0. So that means we're going to split this up into two equations. So I've got x plus 4 is equal to positive 3, or x plus 4 is equal to negative 3, because whatever I get for x there, when I take the absolute value, it'll give me positive 3. So if I solve, the methods for both equations are the same process, subtract 4, and I get x equals negative 1 and x equals negative 7. So what that means is if I plug in negative 1 for x, I'm going to get positive 3, absolute value of positive 3 is 3. If I plug in negative 7 into here, I get negative 7 plus 4 is negative 3. So absolute value of negative 3 is 3. Okay, let's look at the second example. 3 times the absolute value of, 13 minus 2x is equal to 15. Okay. All right, so my goal is to make this one look as simple as the first one. So I need to get the absolute values by themselves. Right now I have 3 times this absolute value, so in order to simplify it, to get it just the absolute values by itself, I'm going to divide both sides by 3. So now I have absolute value of 13 minus 2x is equal to 5. That looks a lot more like the first example. So I know that the stuff, whatever I plug in for x, if that stuff gives me 5 or negative 5, the absolute value of both of those gives me a positive 5. So I'm going to split this up into 13 minus 2x equals 5, and 13 minus 2x is equal to negative 5. So both of them have the same solving process. I'm going to subtract 13 from both sides for both of them. So I get negative 2x is equal to negative 8, and negative 2x is equal to negative 18. Divide both sides by negative 2 for both of them, and I get x is equal to 4 and x is equal to 9. All right, let's do one more example that's slightly even more complicated. So now I've got 3 times the absolute value of 4x plus 2 minus 7 is equal to 11. Again, I need the absolute values by themselves, so I'm going to undo everything else. So first thing I'm going to undo is the minus 7. So I'm going to add 7 to both sides. That gives me 3 times absolute value of 4x plus 2 is equal to 18. Looks like example 2. I've got 3 times, so to simplify to get it to be the absolute values by themselves, I'm going to divide both sides by 3. So that gives me absolute value of 4x plus 2 is equal to 6. And now, whatever's inside of here, if that equals 6, absolute value of 6 is 6, or if it's negative 6, absolute value of negative 6 is also positive 6. So I'm going to go ahead and split it up into 2 equations. Again, they both require the same set of steps. So both of them means subtract 2 from both sides first. So that gives me 4x is equal to 4, and 4x is equal to negative 8. Then divide by 4. That gives me x is equal to 1, and x is equal to negative 2. So what that means is if I plug either of those values back into the original, 4x, and then evaluate, I should get out 11. It is possible for there to be no solution, okay? So if you remember back to when we started our conversation about absolute value, and the idea that absolute value is the distance from 0, I cannot have absolute value equals a negative number because that suggests that I'm a negative distance from 0. There's no such thing as a negative distance. So if I look at a problem, once I simplify, okay, it doesn't matter right now that this is a negative. I have to get the absolute values down by themselves. So I'm going to start my solution process. Okay, so I subtract 6 from both sides, and I'm left with, to get my absolute values by themselves. So this says something is negative 8 spaces from 0. That doesn't make sense. Okay, so this one, because this is negative, you can't have a negative distance. So there's no solution. Okay. Now I could have changed this one slightly to make it where it does work. So we want to be careful. Okay, if I had given you this problem and just changed it ever so slightly, and I made this a minus 6 instead, I don't want to jump the gun and say there's no solution just because there's a negative 2 there. If I add 6 to both sides, I get a positive distance. So through this solution, once we got the absolute value by itself, it came out with a positive distance, so this one would have a solution. So be careful that you don't jump the gun too early to say that there's no solution. As far as the last 2 bits on here with the graph, all I'm going to do is the parent function, the most simple, just so you can see what it looks like graphically. If we have time later on, we'll get to graphing them, but we're not going to do that right now because our focus is more on solving and inequalities. But just so you can see a picture of what. Okay, so you just want to be careful that you don't jump the gun here, because once I simplified this down, I've got equal to 4 here, and that's a positive distance. So this one would have a solution. The last bits of the our graphs, okay, and we're just going to look at the parent function. We're not going to worry about actually graphing these right now. Maybe if we have time later on, we'll get to graphing these, but I just want you to see what it looks like. Okay, so I made a chart of values for the function. This is what we call the parent function here. It's the most simple version of absolute value. And I picked some x values and I plugged them in. So we get this V shape. Now I can take this V and I can shift it around so that the point, the vertex, isn't on 0, 0. It could be anywhere. So I can shift it left and right, up and down. I can even make the width of the V skinnier or wider. Okay, and again, we're not going to focus on that right now. So that last bit you don't have to worry about filling out for now. We're going to actually move into, and I'm going to make a second video for the inequalities. So if you could get that out, we'll fill that out, and when I see you next time, I'll show you how to fold it and glue it in.